Hi everyone, welcome to my November 2013 past paper by Edexcel. We're looking at the Maths GCSE higher tier paper. Now, November is a resit paper, and I think that the November papers are usually more difficult than the summer ones. Now, with the resit stopping, this will be very good revision for you because it gets you practicing very tricky questions that could come up in any exam, to be honest. So without further ado, let's begin. There's your formula page. Question 1. This is a list of ingredients for making chicken soup for 4 people. You might not always want to make chicken soup for 4 people, even though it tells you on the label how to do it, or in your recipe how to do it. And Bill is one of these people who wants to make it for more than 4. He wants to make the soup for 6 people. Work out the amount of ingredients he needs, each ingredient. So, if you know for 4 and you want for 6, you can actually do 4 and think about what half of 4 is. Half of 4 is 2. So, add on half of it to itself, which is the same as times 1.5. Okay? So from 4 to get to 6, you can do times 1.5. So if you've got 60 and you want to know how much for 6 people, times 1.5, well, times 1.5 is the same as having 60, a whole, plus half of 60, which is 30, as long as you're good at halving numbers, which gives you 90. Chicken, half of 300 is 150. So add those up, 450. Cream, half of 150 is 75. So add those up, 225. 1 onion, well, 1.5 times 1 is 1.5. 1.5 onions. Hope you don't waste the other half that's remaining from your 2. 640 chicken stock. So it's going to be half of 640 is 320 and 960 when you add them. I hope I've not gone too quick on the halving numbers. It is something worth being able to do. So let's just write our answer in what's required. 90, 450, 225, 1.5, and going off a page, next one, you can think about what that's going to say. It's going to say chicken stock, 960. Okay, so that's 3 marks in the bag. Moving on to question 2. A publisher checks documents for errors. He records the number of documents that are checked each day. He also records total numbers of errors in the documents. The scatter graph shows this information. Okay, so you can see there's a bit of a pattern. So the number of documents checked is going up, number of errors is going up. And we can show this pattern by having a bit of a line. Now let's use our common sense. If he doesn't check any documents, he can't find any errors. So that's a point that we can put on ourselves. And for our line of best fit, we can try and make it go through the middle of all the points. There's not one correct answer for this line of best fit. You can kind of use your ruler and try and put it in the right place. So this would be where you're testing your ruler out and think, right, that's going to be it, bang in the middle there. There's no one perfect answer. Try and get it as good as you can. On another day, 90 documents are checked. There's a total of 17 errors. Show this information on the scatter graph. Okay, so let's show that. 90 documents are checked and 17 errors. So here's 90 between 80 and 100, and we go up to 17. So it's 16, 17, 18, 19, 20. So 2 of these is going up. 1, 16, 17. So let's draw it across. And from 90. Okay. So it fits in with my idea pretty well there. Okay, that's part A. Part B, describe the correlation between the number of documents checked and the total numbers of errors. So the correlation that we're talking about is positive. Pretend you're reading a book, go from left to right and see, is it going up, which is going to be positive, or is it going down, which is going to be negative? Okay, so it's this one, so it's positive, not that one, which is negative. So you would write for part B, positive correlation. Let's see if there are any more questions for us to do. On one day, 110 documents are checked. Estimate the total numbers of errors. So remember the number 110 here. 110 documents checked. We go up to our estimate line, our line of best fit. We read across. Okay. And mine, this one above would be 21. So it's 20.5. You could do a number 20.5, or you could do a number 20, or you could do a number 21. Okay. It's going to be an estimate, so I'm going to say 20. Okay, 20 documents checked. 20 errors, rather, because you can't have 0.5 of an error. But I don't think you would get marked down for putting a decimal here. It's trying to see if you can read off the chart, really. Okay. Right, clear ink. Question 3. Here's a triangular prism. Work out the volume of this triangular prism. A prism means you've got some random shape at the front, which if you find the area of this, it's called the cross-sectional area. And it's not just in 2D, because it also goes backwards into 3D. And that's how you get the volume of a shape, by timesing this area by this length. So in this specific question, what we've got is a shape at the front of a triangle. Okay, so here's our triangle. Can you see that this same shape repeats all the way through? Imagine a slice of a loaf of bread, and you're slicing it down, and every time you get the same shape. So there's our bread, perfect piece of bread there. Every time you slice down, you're going to get the exact same shape out. That's your cross-sectional area. Okay, so in this case, the triangle is our CSA. Okay, so the vertical height is 4. We're showing that by the 90-degree angle. So the area of a triangle is a half times base times height. Okay, doesn't matter which way around you times these three things. I would actually do the half times 4 gives you 2, times 3 gives you 6. Or you could do 4 times 3 is 12, divided by 2 gives you 6. Same thing. So we found the CSA. Now remember what I said, you want to times that all the way through. So times that by 20. So 6 times 20. Well, 6 times 2 is 12. You've got an extra 0. So 120 centimetre cubed is your answer there. That's 4 marks. That's quite nice. Question 4. Simplify this algebra. Now, can you spot which terms are similar? Okay. So first of all, just look at your numbers. We've got the number -3 and the number +8. Put them whichever way around you want. 8 minus 3 is quite nice. So that answer is 5. Let's do a colour code. Let's look at our x's. And always look at the sign in front. We've got 2x, add 3x. That gives us 5x's. Imagine 2x's in one hand, add another 3x's in another hand. That's 5x's. And the answer of 8 before was a +8. Okay, a positive number. This 4y, it's got no other y's to be friends with, so it's got to stay on its own. 4y plus 5x plus 5. Part B, factorise fully. Factorise is put back into brackets. Okay. Now this might look like it's going to be a double bracket, but it's not. It's a single bracket because it's just got two terms, and I can see that the x is common in both. The first one, it's x squared, which is x times x. Second one, it's 1x. And the number here is 9, the number here is 6. We have another random y, being lonely. Okay, so we need to see what's common in both and take it outside the bracket. So our numbers, we need to think about the times table. What's the biggest times table that's got 9 and 6 in? The answer is 3. Okay. Then you need to look at your letters. You see what you can take out of both. So you can take an x out of both. That's it. There's no other things repeating there. Then you think you've got 3y on the outside. What do you have to times it by to get to 9x times x, or 9x squared? Well, we need another x, and we also need to times by 3. Next one. You think you've got 3x. What do you have to times it by to get 6xy? Well, we've already got the x. We've already got 3, so we need to times by another 2. And we also need this y involved. Then you look at your sign. It's a minus. So that's your answer. 3x minus 2y. Part C is doing the opposite. We're getting out of the brackets. And if you did the opposite here, you should get back to that. That's how you know if you've done it right. You can check that at the end if you've got time in your exam. 4 times x is 4x. 4 times 2 is 8. And it's a plus in the middle. 4x and 8. So a bit of algebra done. Oh, there's part D. These are my favourite types of brackets. I've done a video on this called the banana method. I always draw a banana on there. And we times these 4 multiplications. Each line that you do is a multiply. X times x is x squared. X times 3 is 3x. And it's a plus in front of both. 5 times x is 5x, but it's a minus in front of 1, so it's a negative. 5 times 3 is 15, and it's a minus times a plus, so that's a minus. Now look at how this simplifies your x terms. You've got 3 x's, you take away 5 x's, so you're starting on 3, you're hopping back 5, you're going to get to minus 2. So the answer there is x squared minus 2x minus 15. Don't try and put these together. These are x squareds, these are x's, they're different. Okay, question 5. Jane has a packet of seeds. I wonder what seeds they are. The probability that a seed will grow is 0.75. What is the probability that the seed will not grow? So let's think of the options in life. You've got a seed. It's either going to grow or it's not going to grow. It's not going to do anything else like magically get zapped by an alien and turn into a butterfly. It's either going to grow or not grow. It's a seed. Okay? What is the probability that a seed will not grow? Well, whatever it is, it covers all of our options for the seeds. So it's got to add with the other probability to make 1, which is certain. It's certain that it will grow or not grow. So we can do 1 minus 0.75, 0.25. Jane plants 200 of these seeds. Now, if you think about 0.25, that's a quarter as a fraction. Estimate the number of seeds that will not grow. So we want 0.25 of the 200. Okay, so we want the fraction of 200. We want a quarter of 200. To get a quarter of something, you can divide by 4. So 200 divided by 4. To divide by 4, you can do divide by 2, then divide by 2. Half it, and you've divided by 4. Half 200, 100. Half 100 is 50. Okay, also 25%. So many options. Question 6. Okay, translate the shape A by the vector minus 3, 2. when you're written as a column vector, it's always x first and then y. So our x is horizontal and our y is vertical. And we take this as positive for y, this is positive for x, which is why you always see these things here. Okay. Anyway, let's get on with it. Translate the shape A, -3, 2. So we're going 3 backwards, 1, 2, 3, and we're going 2 up, wherever we start from, 1, 2. Let's grab our shape and let's go for it. So it's going to be 3 backwards, 1, 2, 3, and 2 up, 1, 2. You might be shouting at me saying, but I can't do that on my paper. Here's what you have to do then. Grab a point, it can be any point on the shape, probably the farmost corner, and you take that 1 point, -3, 1, 2, 3, and take that point again, 2 up, 1, 2. That corresponds to this shape. You could do that with all of them, 2, 3, 1, 2, but what you'll actually find is you get the same shape again. Okay, that's it. Clear the ink off. Moving on to the next part. Describe fully the single transformation that maps a shape Q onto a shape R. So Q was this way around, and now it's this way around. So can you see that it's been rotated, it's been turned? Okay, now it's either been turned from Q to R, it's either been turned this way or a long way that way. We'll do the easier one, we'll go this way. So we want to spin it round there. So we've established how much it wants to spin. Okay, now let's think of that as an angle. So it was like this, it's now like that. Can you see how much it's turned by? It's actually turned by 90 degrees. Okay, so if you think, had this shape, start rotating it. Oh, this wasn't a very good one. And you get to here. The angle that it's turned through is 90 degrees. Okay? I'm not showing that too well, because it should be like that, really. 90 degrees. Anyway, the other thing that we want to know, when you're spinning something around, you want to know how much to spin it by, and you want to know where to spin it around. Imagine you're standing still at a point and you have a stick, okay? If you attach something to a stick that long, you're going to spin it around like that. If you stand over here and attach it to the same stick, you're going to spin it like that. Okay, so if you're spinning 90 degrees, different starting places has a different effect. Same starting place, and it's somewhere else, again, different effect. So the point we spin it around is very, very, very important. Now what you can think is you can either use your tracing paper and try and stick it down and see where it's going to spin, or you can imagine that you're trying to go from this point to the corresponding point on the new shape, and how you can draw two lines at 90 degrees to get the same response, okay, to get the same length on each one. So you want a 90-degree angle and you want these two things as the same length. So I would probably advise tracing paper, to be fair. Try the point 0 first, see if that works. Can you see this point is 4 across 1 up, this is 1 across 4 up, and that's the same length. So I've guessed it straight away, 90 degrees. And if we kept spinning this around, we'd get to here. So that's the answer. It probably would have been a bit easier with tracing paper, but I can't show you that too well on the board. So rotate we've spun it around 90 degrees. And which way around did we go? Well, think about how your clock works. You're allowed to watch in your exam, so you always know which way clockwise is. There's no excuse for that. If you go in the other way, it's called anti-clockwise. Rotate 90 degrees anti-clockwise. And you need to say what point around. The point is 0, 0. It usually gets you 3 marks. Let's have a look. 3 marks. Question 7. Rita is going to make some cheeseburgers for a party. She buys some packets of cheese slices and some boxes of burgers. There are 20 cheese slices in each packet. Okay, so let's imagine her cheese slices that she's got here. And she's got 20 of them. Okay, you'd hope your cheese wasn't green. So 20 slices. Let's imagine her burgers, boxes of 12. It's all about visualizing what's going on, I think. Okay, could be 2 rows of 6. Sorry, it's not 3D. You have to use your imagination a bit there. So 12 burgers. Rita buys exactly the same number of cheese slices and burgers. How many packets of cheese slices and how many boxes of burgers does she buy? So let's think of 2 columns. One for cheese, one for burgers. So, first packet she buys will be 20. If she buys more, it'll be 40. Can you see I'm just adding 20 each time, adding another packet of slices? 60, 80, 100, 120, 140, 160, 180. I could keep going, but let's move on to burgers. First pack she buys, she gets 12. If she buys another pack, add on 12, that's 24. Another pack, add on 12, 36. Another pack, add 2 to units, 1 to your tens, by the way. That's 48. Another pack, that's 60. And you can stop when you get to a number that repeats. You see 60, 60? How many packets of each now is the question. So how many packets of cheese slices? 1, 2, 3. How many packets of burgers? 1, 2, 3, 4, 5. So that is your answer. Okay, next part. Rita wants to put 1 cheese slice and 1 burger into each bread roll. She wants to use all the cheese slices and all the burgers. How many bread rolls does Rita need? Rita wants to put 1 cheese slice and 1 burger into each bread roll. She wants to use all the cheese slices and all the burgers. Well, we've just said we're going to buy 60 of each. Okay? So that's 60 bread rolls that you need. Hope that's only 1 mark. Otherwise, it's giving away marks there. Question 8. ABC is a triangle. We can see the lengths are marked algebraically. Angle ABC equals angle BCA. So that means that these angles, this one and this one, are the same. So these are the same. Okay. The length, that means it's an isosceles triangle with these 2 lengths the same, the 2 angles the same. The length of side AB is 3x minus 5. Length of side AC is 19 minus x. Length of side BC is 2x. We can see all that in the diagram. Work out the perimeter of a triangle. Give your answer as a number of centimeters. Okay, well, centimeters is the units, so we just need to give centimeters in the answer. So, perimeter of a triangle. We're going to just add all these lengths together. Okay, so 2x plus 3x minus 5 plus 19 minus x. We've added these 3, that's all. Put them together. So like we simplified the algebra before, got 2x, add 3x, take away x, and that's a take away 1x. So it's just one of them. So 5x minus 1x is 4x. Okay, and minus 5 add 19. We'll put it the other way around. 19 minus 5. It's easier. It means the same thing. Okay, that is plus 14. And it wants it in terms of centimetres. So that's centimetres. I really thought it was going to ask something else, because we didn't actually need to use the angle fact there, did we? Maybe we do need to use it, because guys, notice what I've just done there. I've just thought about the extra information given. I've just thought how long it took me to do this. Now I've just thought about it being 5 marks. And if you've practiced these papers, you think that doesn't feel like 5 marks. It didn't take long enough to be 5 marks. So we're missing something. And you know the information that I drew on originally, showing that these two are the same? Well, maybe we need to use that as well. So what we're going to do is we're going to think, we want this as a number. Okay? And it does say, if I read it properly, as a number. Okay? Not in terms of algebra. So we know that these two are equals because it's an isosceles triangle. So 3x minus 5 equals 19 minus x. Let's solve this equation. We want the x's on this side because that's where there's more of them. So add x to both sides. The rest of it stays the same. 19. Okay. We want to find x, so we add 5, add 5. So 4x equals 24. To find what x is, you now divide by 4 on both sides. Remember the trick to divide by 4? Half it again. Half of 24 is 12. Half of 12 is 6. So we now know what x is without too much difficulty. It's very strange to give you information on a GCSE paper that you don't need, so remember that. So this is 6 instead of x. 4 times 6, 12, 24. Add on 14. 24 add 14, 38 centimetres is your answer as a number, which was what was requested. Now that feels like 5 marks. Now we can move on to question 9. Julia is investigating how much exercise people do in a week. She uses these 2 questions in a questionnaire. Number 1, what is your age? Under 15, 15 to 25, 25 to 40, over 40. So that's the first one. Question 2, how much exercise do you do? A bit, some, a lot. Write down one thing wrong with each of these questions. Do not start answering the questionnaire. It's not for you. You're just analysing it and saying what you think about it and what the problems are. Now, for the first one, what is your age? What if a person was 25? They would not know where to tick. Okay? So 25 is overlapped. And if you are 25, you're going to be very confused filling in this survey. Okay? So boxes overlap for age of 25. 2 possible boxes to tick. Okay. Question 2. How much exercise do you do? This is an awful question for a questionnaire. Maybe in a conversation, this is okay. An okay question, an okay response. But if you want to find out information that you can really analyse, what you need to know is some exact details. And a bit, some, a lot isn't very exact. So you could mention that. The other thing that you could mention is there's no time period. Okay? So it's not how much exercise do you do a week or a month, etc. So I would go for no time period, e.g. per week or per month. Okay. so that you can compare. But there's lots of things wrong with question 2, so that's not the only right answer. Julia wants to know how much time people spend exercising. Okay. Design a question that Julia could use in her questionnaire. So, how much time do you basically think about what you said was wrong and make sure it's right in your question? So let's go exercise per week. So we've got a time period. And then let's give some options, not just a bit, a little bit, even less of a bit. We need some real numbers, okay? So how much time? We could say in hours, add that in. And we could say 0. We could say, or to the nearest hour would be good. To the nearest hour. So we don't have to worry about in between. Okay, so 0, 1 to 3. Now notice I'm not going to start on 3, I'm going to start on 4. So that if someone's done 4 hours or 3 hours, there's only one box to tick. 4 to 6, 7 to 10, and then more than 10, not including 10. Okay, so how much time to the nearest hour do you spend exercising per week? They've got options, and they're tick boxes, and they do not overlap, so that's a good question. The diagram shows the floor of a village hall. The caretaker needs to polish the floor. 1 tin of polish normally costs £19. 1 tin of polish covers 12 meters squared. So I'm just going to write that down. £19 covers 12 meters squared. The discount of 30% off the cost of a polish. The caretaker has 130 quid. Has he got enough to buy polish for the floor? So first off, we are going to figure out the area of the floor to find out how many meters squared we've got, and then we can figure out how much that's going to cost. So that's our strategy. Let's get started. There's 2 ways to do this question. You could split this up into 2 rectangles like that. I do that quite a lot, so I'm going to show you a different approach just to give you some options. Check this out. Imagine that big area. We're going to find that big rectangle and then take away this smaller rectangle, and that will leave us with the floor area. Okay, so that's our strategy. So the big rectangle is 8 up and 16 across, so it's going to be 8 times 16. Non-calculator paper. 10 times 16 is 160. 2 times 16, 16 doubled, is 32. So you want 8 lots, so you've got 10 lots, you take away 2 lots, that's going to give you 8 lots. Okay, so big rectangles 1 to 8. This little rectangle that we're going to take away, let's think about the sides. So it was 6 up to here and 8 all the way, so that means this is going to be 2. It's 9 across to here, but 16 all the way. So that means that we need an extra 7. So the area is 7 times 2, which is 14. Remember, we're taking that away from 128. So total area equals 128, which was a big rectangle, take away 14, which was a little area. Okay, so that's going to be 114 meters squared. We want to know how many 12s go into it. So let's think about our 12 times table. Now straight off think 120, that's 10 times 12. Okay, so if you want 9 times 12, go back 12, you get 108. So if you buy 9 tins, you've got enough for 108 meters squared. If you buy 10 tins, you've got enough for 120. We're at 114, which is between the two. So we won't have enough if we buy 9. We will have enough if we buy 10. So we need 10 tins. So write down your working out. Show the examiner you know what you're doing. 10 tins. Each tin costs £19. Okay? So 10 tins times 19, just add a 0. Would cost 190 quid. But think about the discount. Okay? 30% off. So let's just erase this little drawing and work out the discount over here. Okay, taking away 30%, you can either find 70% straight off, or you can find 30 and then take it away. That's up to you. Both ways work. Either way, I reckon we want 10%. Divide by 10, 19 quid. What I'm going to do is I'm going to do the find 30% and then take away. So we've got 10, we want 30 times by 3. Now, 19 is 1 off 20, and 20 times 3 is 60. But 19 is 1 off, and we've got it 3 times, so take away 3, and that's your answer of 57. Okay, so 57 quid. That's our discount. Okay, that's 30%. So now we want our final calculation of taking away the discount, minus 57 here, and it's going to be knock next door, borrow you 1, 3. Oh, he's going to be just shy, isn't he? He needs 133 quid. So he's £3 off. Okay. He needs another £3. So what was the answer? Has he got enough? Let's just write nice and clear. No, he's not got enough. He needs 133, so he needs another 3 quid because he's only got 130. That is a very functional question. You can see it's a star question. You need to think about what's going on and explain your answer. Question 11. Each day a company posts some small letters and some large letters. The company posts all the letters by first class post. The table shows information. The company posts all the letters by first class post. The table shows information about the cost of sending small letters by first class post and the cost of sending a large letter by first class post. One day the company wants to post 200 letters. The ratio of the number of small letters to the number of large letters is 3:2. So let's write that down. Notice small comes first, so 3 is the small. And large comes second, so 2 is the large. 70% of the large letters weigh 0 to 100 grams. Okay, which is here on the table. The rest of the large letters, which is going to be 30% of large, is 101 to 250, which is here. Work out the total cost of posting the 200 letters. What a very functional question again. Now, here's one thing about ratio. Ratio is basically saying we've got something to share, but we don't want to share it evenly. Imagine that you went into business with someone. You want to start a small business. You had 20 quid, and your friend, who you want to go into business with, had 80 quid. Let's say that you make, you're doing really well. You make 2 grand. Okay? And you're like, well, I gave 20 at the start, my mate gave 80. You're like, okay, tell you what, let's half our money. Let's take £1,000 each. Is that going to be fair? Not really, because look, you put in 20, they put in 80. So a ratio makes sure that you don't share it half-half, you split it up in a certain way. So this says that instead of being half-half, for every 3 small, there's 2 large. So 1, 2, 3 small, 2 large. That's how it's split up. And if we had 10 letters, it would be like that. So when we're sharing the letters, we need to think about groups of 5. How did I get 5? 3 add 2. Okay. So groups of 5 or 5 letters at a time. And we want to know how many groups of 5 go into our 200. Okay. So 200 divided by 5, we can do it like this, bus stop method. 0, carry the 2. 5 into 20 is going to go 4 times. The answer is 0. And we've got, that means 40 lots of 5 letters. Remember, for each 5 there's 3 small and 2 large. So if we've got 40 lots, to work out how many small, it's going to be 40 lots of 3. 40 times 3. 4 times 3 is 12, add the 0 on. For large, watch the magic happen of maths here. It's 2 for every 5, and there's 40. 2 times 40 is 80. Why did I say it's magic? Because we said we had 200 letters, and it adds up perfectly. Okay, same thing could have been done in your business plan before to figure out how much you each need. I'll leave you to think about that one. Anyway, let's get back to the rest of the info. Should we work out the cost of the small first? Because that's going to be easier one. It's 60p a pop, so it's going to be 120 times 60, working in pence. So in pounds, it's going to be, let's just work in pence. Let's work in pence. It's going to be easier. So 60 pence. Right, 6 times 12, if you know your 6 times table, it's 72. And you've got 2 extra zeros. Remember, that's pence. So we've worked out the small cost already. The large cost, 70% of the letters is going to be charged at a certain rate. This rate here. So we want to know 70% of 80. Okay. Well, 10% equals 8. So it's 8 times 7. Which is going to be 56. Okay, and each letter we said costs £1. So it's going to be, this sign means implies, it's going to be 56 quid. Or, in pence it would have been 5,600. But we'll combine that later. Right, 30% we've said here is 101 to 250. Right, so 30% of 80. We know 70% is 56. So 80 minus 56. Sorry, my working out's all over the show. There's a lot to fit on here. It's going to be 24. 24 letters costing you £1.50. So think of that as timesing by 1.5. Okay? So think of it times 1.5. Well, one lot of 24 is 24. Half of 24 is 12. 24 plus 12, you're going to get 36. So it's costing 36 quid. So I'm going to highlight all the costs that we've incurred, okay? And I'm going to change, because we're working in pence for that one, that to £72. Okay, you can see that's 72 lots of 100. So let me highlight for all the costs. This is the small letters. This is 56 quid. We don't need those zeros. That's in case we went back to pence. 56 quid for the lower weight here, the 70%, and 36 quid for the higher weight. So we want to add up this and this and this. So total cost, let's do it over here. You would obviously set this out better in your exam because you've got a big piece of paper to do it on. 72 plus 56 plus 36 is going to be 6 add 6 is 12, add 2 is 14, 1 add 3 add 5 add 7, 12, 15, 16. So your answer is 164 quid. What a lot of money to spend on posting parcels. Hey, but if it does a job, then you might make more money from it, from your business, hopefully. Your business is making money. Right, that's that done then. So let's clear the ink off. How many marks was that? 5 marks. On the grid below, look at this gap here. What a clue that is for you. Large gap. Oh, it's giving you a grid, not a graph here. Okay, fair enough. On the grid, draw a graph of y equals 3x plus 2 for all values of x from minus 2 to 2. Okay, so minus 2 to 2 is important. And y equals 3x. 2 is important. Just done that so I can move up our grid. It's a huge grid. Okay, well that's what we're going to have it as for now. Right, why has it left you a gap then? It's left you a gap because you need to draw yourself a little table of x values and y values. And where do your x values go from? You were told in the question. You start at minus 2, you go on your number line up to 2. Okay. So how do you get the corresponding y values? Well, you substitute in each x value into this formula. The formula y equals 3 times your number, add 2. And this number is going to change each time. Now I'm not going to start on x is minus 2. I'm going to start on x is 2 because it's easier and figure out what y has to be. So when x is 2, it's going to be 3 times 2, add 2. So 6 add 2 is going to be 8. Okay, next one, let's look at x as 1. See what answer we get. This time it's going to be 3 times 1 add 2. So that's 5. Next one is going to be 3 times 0 add 2. Well, 3 times 0 is 0, add 2 is 2. Right, you can either cheat here, or if you're good at minuses, you can do minuses. I'll show you the maths way first and then the cheat way next. Next one, x is minus 1. 3 times minus 1 add 2. 3 lots of minus 1 is minus 3. Imagine I took a quid off you 3 times. You've lost 3 lots of minus of 1. Okay, so your money has gone down by 3. That's minus 3. Minus 3 add 2, think of your number line, 0, minus 3, hop up 2, takes you to minus 1. So some people get confused with that, so let me show you a shortcut. What's the pattern? 8, 5, 2, minus 1. We're taking away 3 each time. Take away 3, take away 3, take away 3. So on minus 1 on your number line, hop back 3, minus 4. Okay. Right, you've got your table of values, which you'll pick up method marks for. Let's count on our grid how many sections we've got. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We've got how many different numbers to plot? 1, 2, 3, 4, 5. So let's go across 2 for each one, or we could even go across 3 for each one. Doesn't really matter. So we need to go from x goes horizontally, by the way. So we're going from -2 to 2 horizontally. Y goes vertically, and that's from -4 to 8. So from -4 to 8, you need to go 4 to get to 0, and then another 8, so it's 12 squares we need, or 12 lines. Let's count how many we've got. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. You might have been able to do a slightly different scale, however, because I'm off the page, I'm going to use this scale. I'm going to start at -4 here. So -3, -2, -1, 0 here. So 0 is where you draw your line across. That is your x values. Now let's think about our x values. We said we could fit in starting at -2, go across 3. Let's see if this works. -1, 0, 1, 2. How cool is that? It's fitted on. So now, where we have 0, this can be our y line, okay, our y axis, and we can draw on these values. So starting at -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So we've covered all bases. You don't always have to draw these grids yourself. Sometimes these are on ready for you. So you can see it's a bit more difficult if you do, but nothing you can't handle, I'm sure. Now let's plot our points. You see this x and then a y? That is a coordinate to plot. Okay? X is 2, y is 8. So you go across 2 and up 8. That's your first point. Next one, you go across 1, up 5, along the corridor before you go up the stairs. Next one, 0 across and 2 up. It's here. Next one, -1 across, -1 up, aka 1 down. Same thing. Okay. So -1, -1, it's here. Last one, -2, -4. So -2 across, -4 down. They should be in a straight line. You grab yourself your ruler. Wow, that went majorly wrong. Grab yourself your ruler, okay, and draw a straight line through all your crosses. If you get your ruler out and your crosses are all over the show and you can't do a straight line, and it's an equation like this, you've gone wrong. Of course, the other option is a graph like that. That will have an x squared in. Okay, this one doesn't. This is called a linear equation. Right, enough of that chat. Anyway, let's move on. You see, you get extra marks. You get 4 marks because you had to figure out the graph yourself and draw it on. Right. Hertford Juniors is a basketball team. At the end of 10 games, their mean score is 35 points per game. At the end of 11 games, so they've played one more, their mean has gone down 33 points per game. This could be a real situation if you're watching sport and you're given a load of data on the TV. How many points did the team score in the 11th game? Right, so we add up all our values and divide by 10 and we get 35. So this means in the first 10 games, so we've added up, we've divided by 10 and we get 35. So that means that what you must have got before you divided by 10 was 350. So the added up value is 350 for the first 10 games. Then what we did was we added on another number, however many we got for the next game. Let's call this number x. We might as well do a bit of algebra. We added on another number, and then we divided by 11. Why did we divide by 11? Because there are 11 games. And we got the answer of 33. And our job is to find this missing value. You could do this without x, you could do it by undoing the operations, but I think an equation is quite nice here. So we're trying to solve, we want x on its own, we want to know what x is. First thing we're going to get rid of is this 11. So divide by 11, to get rid of it, we times by 11. That means we have to do 33 times 11. So 33 times 10 is 330. One lot of 33 is 33, so 363. Okay, so that means we've got rid of this 11. So our equation becomes 350 plus an unknown amount equals 363. To figure out this unknown amount, let's take away 350 from both sides. Okay, so you get x equals 13 points. Okay, so I didn't get many points on that game, but that's your answer. It's quite nice that if you can do maths, you can solve little problems like that. Question 14. Write down the reciprocal of 5. Reciprocal is just a word for 1 over. Okay, it's multiplicative inverse. But you don't need to worry about that. Just remember reciprocal 1 over. Evaluate 3 to the power of minus 2. Now this minus in the power, you might have seen in standard form when you're actually dividing by 10 instead of timesing by 10. It's very similar here. That means we're actually dividing by this whole thing, but without the negative. So you're dividing by the whole thing, but without the negative here. Okay? So what are we dividing? Well, it's just 1 with it, so just 1 divided by it. 3 squared, 3 times 3 is 9. So the answer is 1 over 9. Part C, calculate 9 times 10 to 4 times 10 times 3 times 10 to 3. Okay, now the normal bit of maths here is the normal 9 times the normal 3. So 9 times 3 is 27. The bit of indices laws is if you've got something to a power times by something to another power, you can just add the powers in your answer, as long as this number or this letter is the same, which are numbers and letters, because the numbers just represent a letter or any letter. So our number 10 is going to stay the same, and the power is going to be 4 add 3. 4 add 3 is 7. Okay. So this is another way to write this. However, it's not in standard form. So that's going to give you 1 mark. If you want your second mark, you have to know what standard form is. Standard form is any number between 1 and 10 times by 10 to another number, okay, which is a whole number. So we want it in this form. At the minute it's nearly there because it's something times 10 to the power of a whole number. However, what did I say about A if you were listening there? A has to be between 1 and 10. 27 isn't between 1 and 10. We can't change our number completely, but we can think, hold up, 27, well that's 2.7 times 10. So we're using the same digits and this little times 10 trick. So it's 2.7 times 10. Don't forget this guy on the end, 10 to the power of 7. Well, 10 on its own is 10 to the power of 1. And what did we do before? We added the powers. So that's 10 to the power of 8. So our final answer in standard form is 2.7 times 10 to the power of 8. Question 15. Solve the simultaneous equations. I've done a video on simultaneous equations like these. We use a method called the elimination method. And what I say is we first of all do a step X. We do a step X when the numbers in front of the letters aren't lining up. They're not the same in each column. And the actual name for these numbers in front of the letter is the coefficient. So let's do step X. If you're not sure about this, check my simultaneous equations video out. But what it means is we're going to times by the opposite. So this is a 2 in front, so we're going to times by 2 on top. This is a 3, so we're going to times by 3. When I say times by 2, I mean you times the whole top equation by 2, every single term. So 3x times 2 gives us 6x. Next one, 4y times 2, 8y. What's between? It's plus. Equals 5 times 2, 10. Remember I've said we multiplied everything by 2. Next one, we have to multiply everything on this equation by 3. So 2x times 3 is 6x. 3y times 3 is 9y. 9 times 3, we had to do that a minute ago, 27. It's an equals there, and it's a negative here. Okay. Right. A couple of different ways to go about this one. Just trying to think. Right, don't worry. Let's go on to my normal steps for simultaneous equations. Step 1 is rectangle. Draw a rectangle around the ones that are the same. And can you see that step X sorted us out? Step X made it so that the 6 was repeated. That's why it's so good. Now, there's an invisible little plus in front of anything on its own. If you had the number 9 on its own, you actually mean positive 9, plus 9. So these have got little negatives. In my method, I say stop, and I say if you have the same sign, you want to subtract. So if you have the same sign, which we do, they're both pluses, we subtract, and we subtract the whole equation in columns. So going down our first column first, 6x minus 6x, 0. You should always get below your rectangle 0 if you've done this right. Now be careful here. The next one, my class always get caught up on these. You've got 8y minus 9y. So let's write that out. We don't need the y's because we'll put that in it later. 8 minus 9. That's two minuses together, which combine forces and make a plus. So it's actually 8 plus 9, which is 17. And remember, we're talking about lots of y, so 17y. Next one is 10 minus 27. So you're on 10 on your number line, and you minus 27. Well, if you get back to 0, you've taken away 10. You've still got another 17 to hop back, so it's minus 17 that you hop back to. Okay? Look at that, we've got 17, 17. Our next step is to find y. We're going to divide by 17 to get y on its own. And 17 divided by 17 is 1, but it's a negative. This is negative 1. We found our first letter. Once you've found your first letter, you go back to the easiest equation from the start, which is probably the top one without any negatives. We write that out again. 3x plus 4y is 5. And now we know some information about y. We know information that y is minus 1. Now it's 4y, which means 4 times y. So it's 4 lots of minus 1, which is minus 4. So this equation changes because we don't need the y anymore to 3x minus 4 is 5. We want to get x on its own, we want to find x. First thing we do is add 4 to both sides. So we get that 3x equals 9. Then we want x completely on its own, so we divide by 3 on both sides. And we get x is 3. So what we've done is we've solved it. We can write it again, x equals 3 and y equals minus 1. If you try these, if you don't believe me, try these letters in any of these two equations, and this combination will work out and give you the answer of 5 at the top and 9 at the bottom. Okay? And look, it even had a little place for you to write x and y. 4 marks. This looks a strange question. Question 16. A company makes monsters. The company makes small monsters with a height of 20 centimeters. A small monster, I take it this is a small monster. I'm going to do them even smaller. My monster probably won't be as scary as that. Might not even look like a monster. But I want to get a picture of what's going on. I believe pictures are great for solving maths problems. Small monster has a surface area of 300 centimeters squared. Okay, so surface area 300 centimeters squared. The company also makes large monsters. So let's get another diagram involved. Large monsters, can I do a trick here? Can I take my small one and enlarge him? Right, other software I could, but this software, I'm afraid not. I'm just going to have to draw him again. So this is a large guy. Yeah, I know, it's not much like a monster. Let me give it a scary face then. Okay, so that's a monster. Right, here we go, scary too. That's a large, this is a small. So what's it tell us about the large? By the way, don't spend too much time in your exam doing drawings. Yeah. Company also makes large monsters with a height of 120. A smaller monster and a larger monster are mathematically similar. So that means that literally, if I'd have managed to get my computer to, you know that cursor that does, is it that? And it just literally makes your thing bigger, and maybe you have to hold down shift. So it's the exact same shape. If you're enlarging a square on your computer and you get a new square, you don't put it all out of shape and get something like that where you've just enlarged a bit. Mathematically similar, this is enlarged to this. This is enlarged to this. So they're the same shape. Same shape, just bigger. That's all it means. Okay, so what? So what do we want to know? The surface area of the larger one. And I'm going to really confuse some of you now, I reckon. But let's see. 20 has gone to 120. And we want a scale factor of what we've multiplied by. The scale factor, because 2 times 6 is 12, and all we've done is added the zeros. Okay, the scale factor is times by 6, so that's fine. So the length has been times by 6. Now do not just times your answer by 6. That's what so many people will do in this exam. And I'm going to try and show you on a diagram why that doesn't work and why that gives you the wrong answer. Let's imagine our length is 1 across. We times it by 6. And we get a length of 6 across. Okay, nothing too confusing yet. Okay, now what if we didn't have a length, we had an area? So we went another 1 up here. When we times by 6, we're going to go 1, 2, 3, 4, 5, 6. Just about fitted it on. Okay. So now that has been times by 6 as well. So the height here is 6 and the length is 6. So what we're going to do, by the way, this is just a 1 by 1 square. This is a 6 by 6. Let's erase our info on the same shape thing. Hopefully you've taken that in. What we've got is a new and large square, 6 up, 1, 2, 3, 4, 5, 6, 6 across. They should be perfect, I know. 1, 2, 3, 4, 5. Oh, I bet you guys were not happy when I drew that way. Hope you can forgive my little fix there. Now, 6 by 6, how many squares are there? Well, you could count them all, or you could use maths. Count them all if you want. You're going to get 36. And if you know about area, you know how I've got 36. So hold up, the length was times by 6, but what's happened to the area? The area has been times by 6 here and times by 6 here. So it's been times by 6 and by 6 again, which is the same as times 36. And an area of 1 has gone to an area of 36. So the area, I told you I might confuse some people. The small area, 300, we have to times it by 36, not 6. Okay? And it's a non-calculator paper, so let's think of how we're going to do it. Let's do 3 times 36 by doing 36, add 36, add 36. This first unit's row adds up to 18. The 10s add up to 9, carry 1. 108. But it wasn't 3 we started with. It was 300. So add a couple of zeros in the mix, and you get 108, 10,800, and it's centimeters squared. So it will have a big impact on the change of area, much bigger than the change of length of each of the lengths. Okay, I hope that makes sense. I've tried to explain it as best that I can. Obviously, you wouldn't do all the explaining in the exam, so if you just knew what to do straight away, 3 marks. Find out the scale factor 6, and then times by 6 and times by 6 again because it's area. Right, looks like a 3D question. AB is a line segment. I don't want to confuse you visualizing things. This is 2 marks, so you're expected to do it with just algebra. But somewhere in 3D space, just look around you, that's 3D. This is 2D when we write on a page or see something on a screen. Actually, in real life, it goes into 3rd dimension, which is your extra letter. It now goes X, Y, Z. Anyway, somewhere you've got these 2 points. Okay, A and B. This isn't accurate. You want to know the distance between. Now, if you know how far in the X it's gone from 3 to minus 2. Okay? And we want to know the middle of 3 and minus 2. So you could just think of that as the X direction. You've gone from 3 to minus 2. And you want the middle. Okay? So you could count back and think, well, the middle of 3 and minus 2 is going to be, actually it's going to be halfway, half there. But you don't want to draw these out every time. It's only 2 marks, so what do? To find the midpoint, here's a formula for you. Add 2 numbers, then divide by 2. A little rule for you. That is an important one to learn, to be fair. And if you don't like learning stuff, this is finding the mean of the 2 numbers. And if you already know the mean, then you know what to do. Okay, add them up, divide by how many there are. There are 2. Anyway, so let's pretend that we didn't do this little trick. the middle of 3 and minus 2, 3 plus minus 2, plus and minus make a minus, which give you 1. Divide by 2, it's a half. Okay, or 0.5 as we said above. Let's do that for the y values. 6 add 2 is 8. 6 add 2 is 8. That's 6 add 8. 6 add 2 is 8. 8 divided by 2 gives us 4. And the last one, for the z values, middle of 7 and 5, you might just know that. Let's show off our technique. 7 add 5 is 12. 12 divided by 2 is 6. How cool is that? So we get the answer 0.546. 0.5 for x, 4 for y, 6 for z. Job done. Okay. Moving on. Question 18. Cumulative frequency graph shows the information for 80 swimmers. And they're swimming 50 meters. Okay. And it shows the time. So you can see the time across the bottom horizontally. Cumulative frequency means how many are we up to. Cumulative, you're adding each time. And we have to use this diagram. Okay. Just about fit it in there. So, question A. Use the graph to find an estimate for the median. Median is the middle. Okay. How many people have we got in total? We've got 80 people in total. Okay. So halfway for 80 is 40. Imagine all 80 numbers written out in a list. Middle is 40. So median time is going to be whatever you read off here. Let's figure out the scale. 61, 2, 3, 4, 5. Nope, because that has to be 70. So each one is going up 2. So that is 68. Okay. 68 seconds because it's time. What else does it want us to do? Done part A for 1 mark. A swimmer has to swim 50 meters in 60 seconds or less to qualify for the team. Captain says more than 25 swimmers have qualified for the swimming team. Is the captain right? Wow. Right, has to swim 50 meters in 60 seconds. So let's just talk about that. 60 seconds or less. Okay. So the time is along the bottom. Here's 60 seconds. Let's go up to the graph. Okay. And go across to read off how many. This is about how many cumulative frequency. How many are between 0 and 60, it will tell us. So let's figure out the scale here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each little line is 1. Okay, so 21, 22, 23, 24, 25, 26, 27, 28. So part B, 28 people. Okay, and the chief guy, whoever he was, the coach, was saying that 25%. So 25% of the amount of people. The amount of people is 80. 25% is a quarter. So quarter of 80, just divide by 4. 20 people. So let's read what the coach says again. The coach says more than 25% of swimmers have qualified. And they have to swim 50 meters in 60 seconds or less to qualify. Okay. So let's interpret what we've just talked about. Okay. So 28 people, this is qualified. Okay. 25% is 20 people. 28 is greater than 20, so he is correct. Okay, it's more than 25%. 20 is 25%, so 28 is more than 25%. Right, can we clear this stuff off yet? Do not know. I reckon we can gamble, clear it off. For these 80 swimmers, the least time taken was 28 seconds. The greatest time taken was 96 seconds. Okay. Draw a box plot. So, box plot, you need a min, you need a max, you need the middle, which is median, you need the lower quartile, and you need the upper quartile. Splitting it up into quarters. And this is how you draw it. Sorry, it's on a bit of a slant. Okay, like that. So, our min, 28. So we can go to 28. Here's 30 in the middle. So these are each 2. So 28, we can draw a line. That's our minimum. Maximum, 96 seconds, is here. So there's 90, 92, 94, 96. That's our maximum. Done. We need the other information on here. And I probably shouldn't have rubbed out the median because we need that still. Middle. Oh, I wanted to cheat here, but it's not going to let me. Oh well, doesn't matter. Do not worry. So the middle, we'll do it again because I can't remember what it was. Probably shouting at your screens right now. Middle is 68. So let's write that down. Median, 68. And let's think about what else we want. The lower quarter, well, out of 80, lower quarter is 20. And it looks like it's bang in the middle there. Okay, so here was 50, 52, 53 for the lower quarter. And the upper quarter is at 3/4, 60. Read off down here. It's going to be 70, 72, 74, 76. So upper quarter. Okay. Sorry I couldn't cheat. What I wanted to do is hope they had the same scale, but they don't by the look of it. Okay. So now I can move this stuff out of the way. Don't need those. Right, okay, down to business. Middle, 68, so let's go to 68, there's 70, here's 68, middle. Okay, lower quarter, 53, there's 50, 52, 53 is here. Upper quarter, 76, there's 70, 72, 74, 76. Now remember the diagram I showed you? That's how the box plots always look. So let's make it into that. Okay, and that's job done. Okay, yours would all be the same colour probably, but and you would use a ruler obviously in your exam. Okay, 3 marks for that one. Question 19. In a supermarket, the probability that John buys fruit, so probability of getting fruit, is 0.7. In the same supermarket, the probability that John independently buys vegetables is 0.4. So probability of him getting his vegetables is 0.4. Work out the probability that John buys fruit or buys vegetables or buys both. So you can imagine his shopping trolley. Okay, he might be chucking in some fruit, he might be chucking in some vegetables, he might be chucking in both, or he might not be chucking in any. So we need to think about the probability of not fruit. Well, if it's 0.7 of fruit, take it away from 1 to get 0.3 of fruit. Not fruit, other way around. Probability of not vegetables, 1 minus 0.6. 1 minus 0.4 is 0.6. Okay, so we've got all the probabilities we need. Now you could think, well, we want the probability of fruit times the probability of veg from getting both, plus the probability of fruit times the probability of not veg from getting just fruit, plus the probability of him getting veg times the probability of him getting not fruit for just veg. But I want to show you a quicker way, because that is every single possible option apart from no fruit, no veg. So if we do 1 minus probability of not fruit times the probability of not veg, that would do the job for us. Okay, so probability of not fruit is 0.3, probability of not veg is 0.6, so it's 1 minus the answer to that. 3 times 6 is 18. However, we're moving the decimal point twice, so it's to here 0.18. So 1 minus 0.18, think of 100 minus 18, and then put 0. The answer, 0.82 is your answer to that question. Okay, clear ink. Moving on to question 20. We've got some algebra here. Solve 4 times 8x minus 2 divided by 3x equals 10. Okay, so your aim is to find x, so ideally we want x to be on its own so that we can figure out what it is. So we've got quite a lot of stuff to do here in terms of algebra, which is why it's 3 marks. The first thing to do is think we do not like this x on the bottom, so let's times by 3x to both sides of the equation. That means that we're just left with the stuff on the top, and on this side 10 times 3x is 30x. Now you can do this in either order. I think what I'll do is I'll times out this bracket, but you could actually just divide by 4 here. 4 times 8 is going to be 32, and it's x. 4 times minus 2 minus 8 equals 30x. Now we can take 30x from both sides, and on the left hand side 32x minus 30x leaves us with 2x, and we've still got this minus 8, and we've got nothing left here. We had 30x, we took away 30x, we've got 0. Right, add 8 to both sides of the equation, so we get 2x equals 8. Divide by 2, divide by 2, and we get that x is 4. Okay. Right, part B, algebraic fractions, write as its simplest form. Now, if you watched my smiley face adding fractions video, this method works perfectly when you've got algebraic fractions. It's actually really, really nice to give you the algebra. So I'm going to do that smiley face method. So each line on our smiley face we multiply. And it's very important, the format. There's a one big line, and then this minus will go into the middle when we're done. So multiplying on the first line, 2 lots of y minus 6. Okay, so extend this more. Second line, 1 lot of y add 3. We keep it together. And on the bottom, the final multiply, y add 3 multiplied by y minus 6. What goes in the middle? Well, can you remember? It was a take away. Okay, so that goes in the middle here. Okay, now we multiply out these brackets. So the first one goes to 2y minus 12. And this is a negative of both in the second bracket. So it's minus y minus 3. Think of that as minus 1 multiplying in. I'm not going to expand out the bottom row yet, because there might be something nice that happens. Might not be. We'll see. Okay, right, can we move all that across to give us space to do some working out? Okay, just figure out the top row. You've got 2y, you take y away, so that's going to be 1y left, and you've got minus 12 minus 3, which is minus 15. Y at 3, y minus 6. How many marks is this to see if we have to do any more? 3 marks. That could be the final answer. But let's just check that there's nothing that's going to happen on the bottom row. You'll see what I mean in a minute. So y minus 15 over, let's expand out this with the banana method. So it's going to be y squared. There is shortcuts for doing this. You can add these numbers, 3 and minus 6 to get minus 3y, and times these numbers to get minus 18. Okay, now I just want to know if this is going to factorize to have a y minus 15 on the bottom. So two numbers that multiply to make minus 18 add to make 3. No, it's not going to happen, so just ignore what I just said and leave that as your final answer. Okay? 3 marks. Question 21. Y is directly proportional to the square of x. So y has a relationship with x where it's proportional to x squared. And that means to get y, it's going to be some random number, whatever it is, times by x squared each time. And our job is to figure out this, I said random, this constant k. We know that x equals 3 when y equals 36. So let's substitute in these values. Y 36. We're still trying to find out the value of k. And it's times by, so multiply, 3 squared. 3 squared is 9. So that means that 36 equals 9 times k. Divide by 9 to get that k is 4. So that means you can write this equation again, and instead of k, you've now got a 4 there. Okay, so that's your equation. That will tell you y, depending on what your value of x is. And the next bit says, find y when x is 5. So we're going to do y equals 4. Instead of x, we're going to put the value of 5 in. Okay, for that. So 5 squared is 25. So it's 4 times 25, which is 100. Okay, and that's for 4 marks. Not too bad. Question 22. It's a starred question. Looks like a circle theorem, but the interesting thing on this question is it's not actually given any numbers. We're only given an angle as an unknown y. Okay, so A, B, C, and D are points in the circumference of a circle, centre 0. Angle AOC equals y, which is what we just labelled on. Find the sides of the angle ABC in terms of y. So this is our mystery angle here. Okay, so let's go about our business. Find, give a reason for each step in your working out. Now, can you see the Star Trek sign? I've done a video on circle theorems if you want to check it out, but that is related to these two things. And it says that the angle at the circumference, or the angle at the center, is double the angle at the circumference. And the thing that it says is when subtended from the same arc. So that means you've got an arc here. There's going to the center. There's going to the circumference. Can you see they're coming out of the same place? That's all it means. But it is important. Otherwise, you could just draw on any random angle. Okay, so I'm going to add that in. Subtended from the same arc. Okay, so what does that tell us? That tells us that angle ADC is half of y, isn't it? Okay, because the centre one is double it. So it's half of y. Half y. Okay, that's the first bit done. The next bit is, can you see that we've got this four-sided shape inside a circle? Okay, when it's inside a circle, that's a cyclic quadrilateral. And in a cyclic quadrilateral, opposite angles add up to 180. Okay, so opposite angles in a cyclic quadrilateral add up to 180 degrees. So that means that this mystery angle, angle ABC, plus our angle here, angle ADC, which we already have found out, equals 180. So I've said we've already found this out. It's a half y. So therefore, angle ABC equals plus a half y equals 180 degrees. Now we just want an equation for angle ABC. So all you're going to do is take that to the other side by taking away half y. Okay, job done. Quite a strange one because it's all in algebra, but it's the same rules that apply. Question 23. On the grid, enlarge the triangle by a scale factor of -1/2. Centre, 0, -2. First thing you want to do is you want to draw on your centre. So along the corridor, before you go up the stairs, and this time we're going down the stairs because it's a minus. So 0 across, 2 down. That's your centre enlargement. So that's very important. -1/2. So this is going to be scale factor -1/2. Okay. Now, the scale factor of -1/2 means that you count backwards. Okay, when it's a negative. And that actually transforms the shape. We'll see what happens. Now, let's colour code. So, first corner, second corner, third corner. To get from the centre of enlargement to this first corner, we go 1, 2, and then 1, 2, 3, 4. So 2 across and 4 up. We're timesing by -1/2 here. Okay, so instead of going 2 across and 4 up, 2 times 1/2 is 1, and negative means you're going to go backwards. So we're going to go back 1. 4 times 1/2 is 2, and it was going up, so we're going down now. Down 2. So let's do it for our blue one. So 1 across, 1, 2 down. That's this new point on the triangle. Okay, let's do the green one. So the green one we did go 1, 2, 1, 2, 3, 4, 5, 6. So it was 2 across, 6 up. Half it and do the negative. So it's going to be going 1 across. Sorry about that. I don't know what's going on here. It's going to be 1 across, and half of 6 is 3, and it was going up. Negative is going to make it go down. Let's do that one in green. 1 across, and 1, 2, 3 down. There it is. The red one, this is going to be a tricky one. You'll see what I mean in a second. 1, 2, 3, 4, 5, 6 across. 1, 2, 3, 4, 5 up. So the 6 across is okay. It was going 6. It's now going to go backwards because it's a negative, and it's going to go half because it's minus a half, so it's 3. The 5, but it was going up, it's going to go to half of 5, which is 2.5. Instead of going up, it's going down now. So let's go from the center. Look how busy the center is. 1, 2, 3, and 1, 2 and a half. So a new point goes, and then we can draw our triangle. So can you see it's flipped it around? And that's what happens when you have the negative scale factor. Now, I always recommend drawing guidance lines. So let's get rid of these jumping lines that we were putting on. And actually, if you're confident with these, you might just be able to do this question with these projection lines that I'm going to show you now. So this projection line, the first one, it went like that. You can go backwards to that, half of it. Okay. The second one, it went up like this. Go backwards for half of it. Can you see how you could have done this in your head without the jumping stuff? I'd just like to show you the exact way as well. This one's harder. Do that and then half of it. But you could have just thought, well, we're going backwards and we're going to do half that length. Right, those projection lines, check everything's in shape because they should go to each other. Okay. There's only 2 marks, so projection lines are a much more efficient way. OACB is a parallelogram. OA is a vector A, so let's draw that on. So vector A. Okay. And OB is a vector B. Let's draw that on. Okay. D is a point such that AC equals CD. Fair enough. So from A to C is the same as C to D. The point N divides AB in the ratio 2 to 1. Okay, so from A to B, you go 2 across and 1 here. It splits it into 3. Okay, they're thirds. Write an expression for ON in terms of A and B. ON. Okay, so from O to N, let's do it in highlighter to see where we're trying to go. We're trying to go up here and then here. Or, alternatively, you could go, show you a different route in green, along here, up here. Okay, both will give you the exact same answer. Now, let's think about how to get from A to B. So to get from A to B, okay, what we need to do is we need to go backwards along A, so that's minus A, and we need to go forwards along B, so that's plus B. Okay. If we want to go from O to N, we'll go forwards up A. So we'll go forwards up A. And then we'll add on 2/3 of OB. So that's saying that to get from A to N, you go 2/3 of the way along for A to B. So it's 2/3 of each. Okay, so we're going to add this on, which is going to be minus 2 over 3A plus 2 over 3B, which gives us 1 whole A is 3 over 3. So that's going to be a third A plus 2/3 B, which is our answer. Okay, that's ON. See if we can do the last part. Part B, prove OND is a straight line. So OND Prove OND is a straight line. Ah, wow, that's an interesting question. Look where OND is. O to N to D. It wasn't even drawn in for you. It's there. Okay, just pretend that I've done that with a ruler. It's nice and straight. Prove that's a straight line. Okay. So how are we going to prove that? Well, let's think about going from O to D. We can go up A to get to here. So we're at this point, and then we can go B, which is the same because of its being a parallelogram. Okay, so it's going to be plus B, and then we've said they're the same already, so plus another B. So plus 2B. So how does that prove it's a straight line? Okay, so I know what we're doing. It's a straight line if this is straight and this is straight. Basically, if you've got 3 points in a row, 1, 2, 3, if you draw a line from here to here, it's going to be part of the full line. If they're not straight, the points, what will happen is that this line will be off from this line, and they're not straight. So this one is straight, this one isn't. We know O to D, okay, that's that. And we also know O to N because we just found it. It's quite a challenging question. Okay, O to N is this. A third A plus 2/3 B. Okay, we can factorize out the third because they're both divided by 3 and get A plus 2B. Now remember, A plus 2B is ON, okay, which equals a third ON. Okay, so we can say sorry, that should be OD because we took this one, didn't we, which is OD. So therefore, straight line, because one is a multiple of the other. Okay. And we can say same direction if we want to give more of a reason. Same direction. Okay, so that's a tricky vectors question. I told you there would be some tricky ones in this exam paper. And that's it. That's the last one. So it's 3 marks for each of these, 6 in total. Like I said, November can be a bit strange in November papers. I think some of those questions are much harder than some of the normal ones you get. And I reckon that they're going to be making them this hard from now on. So watch out. But if you keep working hard, you'll be okay. So don't worry about that. I hope you're doing well in your revision. I hope you're working towards the grade that you want and it's going well for you. And all the best in your maths work. Achieve maths. Thank you.